Welcome. Now we start a new section on firm behavior. In this video lecture we're going to focus on firms in competitive markets. In a subsequent lecture we're going to look at monopolies. So in this video lecture we're going to start with the basics, introduce some key concepts. Then we're going to look at the cost structure of a firm. And then we're going to look at the revenue structure of a competitive firm. And then we're going to put those together to look at how firms behave or how they should behave. So first, the basics. And we're going to focus on three behaviors for a competitive firm. First is profit maximization, meaning how can they set their production level so that they can maximize their profits. Now, one thing to keep in mind is in a competitive market, firms do not have control over the price. All they have control over is where to set their production. Second decision we're going to look at is a shutdown decision. And this is a temporary decision to stop production with the intent to restart production at a later time. And then we're going to look at the exit decision, and that's a permanent decision to stop production. So there's no intention to restart. You close operations or you close your business for good. And the distinction between shutdown and exit is one's temporary and one's permanent, and that's going to be a fundamental element on trying to determine when those decisions should be made. So let's first look at economic profit. We know profit is total revenue minus total cost. So this could be more explicitly expressed by TR equals Q times P. The quantity sold times the market price. The total cost is going to be the explicit cost, meaning capital, labor, R&D, and the implicit cost, which is opportunity cost, which we've talked about throughout the course. So the explicit costs, those are the things that you're likely to get a receipt for, and it's going to be on your books that you had that cost. An implicit cost, you likely do not receive a receipt, and it's not on your books. So here are some examples of implicit cost. One is foregone income from labor. So if you own your own business, on the books you have revenues and you have costs, but one thing that's not on your books is what you would be earning if you had a different job, even a different business, or if you were an employee of a big firm. And that's an implicit cost because that alternative employment is a factor in your decision to own your own business and how you run your own business. For college students, full-time college students that put off getting a full-time job until after graduation, their implicit cost of going to college is their foregone income that they would have earned during those years of college. So the explicit cost might be tuition, room, and board, but there's an implicit cost of what you gave up in terms of income and also experience. Another example would be foregone return on investments. So if you invest in a project as a firm, the one implicit cost of that investment is the return that you could have gotten by putting those investments in another project. So the things that you passed up. Another example similar is when you pick a stock and invest in the stock, that stock provides a return. Implicitly, you gave up an alternative return by not purchasing a different stock. That opportunity cost is an implicit cost in that decision. So let's explicitly compare economic and accounting profit. So we've alluded to this before. Accounting ignores implicit cost. It looks at just those things that you get a receipt for or is on your books. Economics includes all those costs, but also include the implicit costs because they affect decisions and affect behavior, and we're interested in those issues. So what we end up with is economic profit is always going to be less than accounting profit. And that's because economic profit adds an additional cost. So now let's move to the cost structure of a firm. Costs are key in determining the best production level and the cost structure itself. And given that we're interested in implicit cost, determining those costs are not always easy. We start with productions and costs levels and identifying that there's a link between production levels and cost. And to see this connection, we're going to first look at the production function. So the production function is the relationship between the quantity of inputs you use and the quantity of outputs you produce. So it's the level of inputs, or the number of inputs related to the number of outputs. Now obviously the more output you have, the more input that you need. But the key here, and the key is going to run through the entire cost structure, is that inputs to outputs is not a one-to-one relationship. Right? You can't just double inputs and double outputs. Might make more sense if you think about it. If the inputs and outputs were a one-to-one relationship, then if a firm produced any amount, then they would just produce an infinite amount. They would never stop. But that's not what we see, because we see that firms produce up to a point and they stop. And they stop because there's a point where cost of producing more begins to dominate the revenue or the benefits of producing more. This lack of a one-to-one relationship is the fundamental reason underneath that decision, and that's where we're heading, is trying to identify that break point or that break-even point. So what we're going to do is go through an example, use an example, John's Pizza Joint, to illustrate the production function, but we're also going to extend that to look at some other issues as well. So let's first look at, for John's Pizza Joint, we look at inputs and outputs. Inputs that we're going to look at is the number of workers. The output is going to be the number of pizzas. Right, so we have a schedule here where workers, you have 0 workers all the way down to 5 workers and the different outcomes. And then with these individual cases of 0, 1, 2, 3, 4, 5 workers, you can have a schedule of how much output will be generated from those inputs. And what we introduce here is something called marginal product of labor. And that's the increase in output due to one additional unit of input. So going from 1 worker to 2 workers, you've added 1 worker, going from 1 to 2. What does that do to output? Looking at these numbers, we see, well, with one worker, we could produce 10 pizzas. If we added a second worker, we could produce 18. So what's the marginal product of that second worker? And that would be 8, and so forth. So going from 2 to 3 workers, that adds 4 units of production, 4 pizzas. Going from 3 to 4 adds 2, and 4 to 5 adds 1. And what we see here is for every additional worker that you add, their marginal product is lower. And that's the concept of diminishing marginal product. It's a general rule that marginal product falls as you add more and more. And one thing to keep in mind, which might help understand that concept, is that everything else is held constant. Right? So we have the fixed number of stoves, a fixed number of registers, a fixed number of square feet in the store. So by adding more and more workers, you're eventually going to get to the point where those additional workers are going to have less to do. And even the marginal product of labor might become negative because they can start getting in each other's way, undermining the workers' productivity. So now let's look at the production function graphically. And what we see is, as you increase inputs, output increases, but it increases at a decreasing rate. This graph puts quantity on the vertical axis, and what we're used to seeing is quantity on the horizontal axis, right? So keeping that in mind, what we see is, as you add inputs, quantity increases, but it increases at a decreasing rate. And that's because of the diminishing marginal product. So let's look at the total cost curve. The total cost curve illustrates the relationship between the level of output and total cost. So whereas the production function looked at output and input, now we're taking that step and looking at output and cost. So let's break total cost down into categories. There are fixed costs, and those are the costs that are unaffected by the production level, right? So there's a building lease payment or employee benefits, and those costs are fixed. No matter what production level you set, you still have to pay those fixed amounts every period. But then you have variable costs that are affected by production level. So if you increase or decrease production level, these costs will change. So that's electricity, gas, and wages, and those things. And then the total is going to be made up of the sum of fixed and variable costs. So now let's extend the pizza joint example to look at the costs. So before we had number of workers and number of pizzas as the inputs and outputs. Now let's look at the costs. Let's first look at the cost of pizza place. So you could think of this as the lease. Maybe it's $50 a week. The cost of workers, each worker costs about $10. Total cost would be the sum of the fixed cost, the pizza place, and the variable cost, the cost of the workers. And what we end up with is an increasing cost, but it increases because of the variable costs. The fixed cost is a constant. So now let's draw the total cost curve for the pizza joint. From the previous slide, I've brought over the number of pizzas and the total cost because that's the two variables we're interested in relating to each other. And this is the total cost curve. And you can see that as you increase output, costs increase, but it increases at an increasing rate, right? So each additional output costs more than the previous one. And if you can guess, the intercept of the vertical axis is going to be the fixed cost, or 50. So now let's look at average total cost. And this relates the level of output to the average total cost. So this is just essentially taking total cost and dividing it by Q. Right? So average total cost equals total cost divided by Q. And you're seeing how average total cost varies over output levels. All right, so from before we have the number of pizzas, and now we have total cost from before. Now let's calculate average total cost. All right, so if we have a total cost of 60, and then your output is 10, what's your average total cost? That's 60 over 10, which is 6. All right, and if you have output of 22 and your total cost is 80, 80 over 22 is 3.6. So you have an average total cost for each production level. And what you end up with is a curve that looks something like this. Average total costs go down to a minimum point, and then it starts to increase. Now let's look at average fixed cost. So this is taking the average total cost and breaking it up. We're going to look at average fixed cost, and next we're going to look at average variable cost. So essentially we're just separating out the average total cost into average fixed and average variable cost. So we're relating the level of output Q against average fixed cost. And average fixed cost is the fixed cost over quantity. Right? So before we had total cost over quantity, now we have fixed cost over quantity. So going back to John's pizza joint example, again we have the output and we have the cost of the pizza place, which is the fixed cost that we had in this example. Right? So that's the same no matter what the production level is, which is the definition of fixed cost, right? So the average fixed cost is going to take that fixed cost value and divide it by the output. So obviously, as you increase output, average fixed cost is going to fall. It's going to continue to fall because what you're doing is you're increasing quantity, but the costs stay the same, so the average is going to go down. And graphically, it's going to look something like this. Right? It's going to go down, it's going to keep decreasing, and it's going to continue to decrease, but the rate at which it decreases declines. So now let's look at average variable cost. So we're going to do the same thing here, look at output and how average variable cost changes as you change output levels. So average variable cost equals variable cost over the quantity. So now let's look at the number of pizzas, which is the output, the Q, and then you have the cost of workers, which is the variable cost. Right? So that's increasing as output increases. So the average variable cost is going to take the cost of workers and divide it by the number of pizzas. Right? The average variable cost over quantity. So if you have 10, the cost of workers is 10 and your output's 10, then your average variable cost is 1 unit per pizza. If your cost is 20 and your output's 18, it's 1.1 and so forth all the way down. And what you see is the average variable cost increases as you increase production. And this relates back to the fact that there's diminishing marginal product. Right? The average will go up. The average variable cost will go up as you increase production level. So what does this look like? Continuous increase as you increase production level. So now let's look at the marginal cost curve. And this is really going to be the critical cost curve that we're going to keep in mind on the cost side of the equation. Marginal cost, and we've talked about marginal issues before, marginal cost curve illustrates the relationship between the level of output and marginal cost. And you remember marginal cost is the additional cost of producing one more unit. And what we're looking at is how does that marginal cost change as you increase or decrease output. So what we're going to do is look at output, and we're going to look at total cost for each output level, and we can calculate marginal cost. Right? So if we go from 0 to 10 pizzas, the cost goes from 50 to 60. Right? So the cost went up by 10. So the output went up by 10, the cost went up by 10. So the marginal cost is 1. Right? If you go from 22 to 24, output went up by 2, but your costs go up by 10, 80 to 90. Right? So 10 over 2 is 5. Right? And so forth. The last one, 24, you're going to 25, so you're increasing output by 1 unit. And the costs go up 10. So that marginal cost of adding that last unit is 10. And what you see here is marginal cost increases as the output level increases. So this looks similar to the average variable cost, and really that is where this is coming from, but the marginal cost curve includes total costs as well. So now we've gone through the different elements of the cost structure. Now let's put it all together on one diagram. And it might look messy, but hopefully, since we went through it one item at a time, it can make some sense, right? We have average fixed cost, which decline, and it continues to fall as you increase production levels. You have average variable cost, and that increases as you increase production levels because of diminishing marginal product. Average total cost is the sum of average variable and average fixed cost. Right? So that's why you see a decrease initially in average total cost, but then it minimizes and then it starts to increase. And that's because early on it's dominated or mostly driven by average fixed cost. So it's declining with average fixed cost. But average fixed cost gets less and less important, and average variable cost gets more and more important. So it starts to take the shape of the average variable cost curve. All right? So that's why you get this U-shaped average total cost curve. It's a combination of the average variable cost and the average fixed cost. And then you have the marginal cost curve. And like I said, that's upward sloping because of that average variable cost and fundamentally because of that diminishing marginal product. All right, one last thing to keep in mind is if you notice, marginal cost increases and crosses average total cost. And one thing to keep in mind is that at marginal cost crosses at the minimum point of the average total cost curve. And we'll talk about that in a second on why that's the case. But what we have here is all of these different cost curves, and now we have some understanding of why they're shaped the way they are and their relationships between them. And what we can do is put all of this up on one slide so you can have it in writing. First, the marginal cost increases with output. We talked about that and how that's driven by the diminishing marginal product. And then we have average total cost, which is U-shaped, and that's because it's a combination of average fixed cost and average variable cost. And then we talked about marginal cost crosses at the average total cost minimum point, right? And we didn't really explain why that's the case, but here's a little explanation. Think of your GPA, the latest grades that you just received, right? Average total cost is like your GPA. It's your GPA is your average grade. Marginal cost, that's like your latest grade that you just earned, right? So you have a new grade, and that affects your GPA, right? If your new grade is greater than your GPA, then what's going to happen? Your GPA is going to go up. And if your new grade is less than your GPA, it's going to pull your GPA down, right? So it's the same intuition here. If the marginal cost is greater than the average, then it's going to pull that average up, right? If the marginal cost is less than the average, it's going to pull that average down, right? And so that's why it's going to cross at its minimum point, because the marginal cost is going to switch at that point from pulling the average down to pulling it up. So that's the end of the cost structure. Now we're going to look at the revenue side of the competitive firm. Now we have total revenue, which we've mentioned before, and that's price times quantity. And P star indicates it's the equilibrium price, and in a competitive market, that equilibrium price is set by the market. The firm does not influence that price. As we said before, in a competitive market, the firm is a price taker. They have to accept that price as a given, so they have no influence on that price. Average revenue is essentially the total revenue over quantity, right? So that's total revenue over quantity. If you rewrite total revenue as quantity times price, then you have Q times P over Q, and the Q's cancel, so you end up with just P, right? So average revenue equals P. And that makes sense because if the price is fixed, whatever the firm sells, it's going to sell at that same price, right? So you sell 10 units at one price, the average is going to be the same as if you sell 20 at that same price, right? The price is fixed. And then you have marginal revenue. If you sell one more unit at the same price, then that marginal revenue is going to be the same. A key result for a competitive firm is that price equals marginal revenue equals average revenue. And that's because the price is fixed across production levels, right? The price is the same for all quantities that you might produce. Thus, the average is the same and the marginal is going to be the same. So graphically, what we end up with is at the market price, P star, is a horizontal line which illustrates, well, that's the marginal revenue and that's the average revenue for any given production level. So the revenue structure for a competitive firm is quite simple and straightforward. It's a horizontal line at the market price. So now we can put the two together, the revenue and the cost structures of the firm. So let's graphically put them together, and we're just putting part of the cost structure up because those are the most important curves, the marginal cost curve and the average total cost curve. Now that we have revenue and cost put together, let's look at some decision making that the firm has to undertake. First, we're going to look at profit maximizing point. And what that is what production level should a firm choose to maximize its profit? And the short answer is it's going to be where marginal revenue equals marginal cost. Now why? And we've talked about this before early on when we looked at marginal decision making. It's the same process. If marginal revenue is greater than marginal cost, meaning that by producing one more unit, it's going to generate more additional revenue than additional costs. So in that situation, what would you want to do? You would want to produce more. Your additional revenue is greater than your additional costs, so you can add to your profit by increasing production. But if you have the opposite case where marginal revenue is less than marginal cost, that means that if you produce more, your additional revenue is going to be less than your additional cost. So your costs are going to be greater than your revenue. So in this case, you're not going to want to produce more. You might even cut back production. So in between those two cases, you have a point where marginal revenue equals marginal cost. And that's the break-even point. And that's where you would want to stay. That's where the additional revenue and additional cost are equal, and that's your break-even point. So let's look at it graphically. So you set quantity. This is like the graph before, but now I've added quantity. And that quantity point is at that intersection of marginal revenue and marginal cost. And the average total cost, that's added there because that illustrates at that point, average total cost is also minimized. So at this point, firms can do no better in terms of profit than setting their production at the level that equates marginal revenue and marginal cost. All right, so now let's look at the shutdown point. As I mentioned before, this is a temporary stop in production with the intent to restart later. Given it's temporary and you have an intention to restart your production later, this is characterized as a short-run decision. So we see that a lot in this area where you shut down the ski slopes in the summertime. In the wintertime, there's some stores that shut down. So there's seasonal reasons why you would want to shut down temporarily, but it might just be market conditions. If you drive out west, you see the oil rigs running. Sometimes they're on, sometimes they're not. Sometimes it's profitable to run those rigs, and sometimes it's not. So the key here is that we're talking about a temporary or short-run decision. So given a short run, all we want to consider in this decision are the things that we have control over, or the things that would change with this temporary decision. So what we're interested in is total revenue is less than the variable cost of productions, because variable cost, those are the things that we can change by changing our production level, right? So if we shut down, production is at zero, we can make variable cost zero. So we can eliminate variable costs. So we have control over that. Fixed costs, on the other hand, those are more permanent, and our production decisions are not going to influence those fixed costs. So all we're interested in is variable cost, right? So we're going to shut down if total revenue is less than the variable cost of production. So that's just TR is less than the variable cost, VC, right? So just reworking this a bit. We know total revenue is the same as P times Q, so we can replace TR with P times Q. So we can have P times Q is less than variable cost. And then we can divide through by Q, so we end up with price is less than average variable cost. And that is the shutdown rule. If price is less than average variable cost, we would want to shut down. If price is above average variable cost, we would want to restart. So the third decision that we're going to look at is the exit point. So this is similar to the shutdown rule, except for now we're talking about it's a permanent decision. So it's going to permanently end production and you have no intention of restarting it. So this is a permanent or a long run decision. So in this case, we're going to use all cost or total cost in the decision. All right, so we're going to exit if total revenue is less than the total cost of production. Because if we exit, we can eliminate all of the cost, not just variable cost. So we can write this as TR is less than TC. Total revenue is less than total cost. So we're rewriting total revenue as P times Q again and dividing through by Q. We can isolate price and use that as the signal. So price being less than average total cost, that would indicate that you should exit the market. And that's the exit point. So you want to exit if price is less than average total cost. So those are your three decisions. You have a profit maximizing point, which is marginal revenue equals marginal cost. A shutdown rule, which is when price is less than average variable cost. And then you have an exit point, and that's when price is less than average total cost. Right? And in this exit point, you can reverse that. So if price is above average total cost, you would have an entry point, right? So you would want to enter the market if price is above average total cost. And this exit and entry is what we have in a competitive market. So that's the end of this video lecture on firm behavior in competitive markets. Be sure to read the text and review your notes, and feel free to revisit parts of this video lecture that you would like to review.